where learning never stops.
Ayan. So, good morning, grade 8 learners. Ayan. Tayo ay nandito na sa ating week 2 ng ating second quarter. And syempre, earthquakes pa rin ang pag-uusapan natin. Continuation ng lesson natin last time. Ayan. So, bago ako mag-start, batiin muna natin ang aming principal, Sir Francis Kenneth Hernandez, and of course, the master teachers of Science Department, Mama Janice Reyes and Ma'am Mary Ann Castro. And of course, our head teacher, Sir Nicanor Reyes II. Ayan. And of course, yung mga grade 8 science teachers namin na laging very supportive sa aming mga live. And of course, may imbitahan natin sila during the next weeks. Ay kasama na natin sila dito sa ating live discussion. Okay? So, let's start our discussion para sa araw na to. Ayan. So, ang title natin is The Quake Starts. Ayan. So, titingnan natin how an earthquake starts na ba. Okay? So, pero bago yan, kamustahin natin ang ating mga students. Ayan, I know I late ang notice natin, pero I know nabanggit ko to before. Last week na Monday tayo mag-live discussion. Pero sige, tingnan natin. If you are happy, sad, feeling loved, and feeling accomplished, nakapagbigay na ako ng enrollment keys sa Moodle natin, sa LMS natin, and I hope ay nakapag-enroll na kayo sa science course natin and hindi kayo naligaw. And of course, naka-open na rin yung iba nating mga activities doon. Baka meron ng mga nakapag-answer. Ayan. So, before we begin the discussion, balikan natin, i-recall natin yung lesson natin last week, which is on earthquake. We define earthquake as the sudden shaking of the ground, which is caused by the shifting of rocks. And of course, earthquakes occur on our faults. Tingnan natin next. Ayan. And they can happen anywhere without warning. So, ito yung sinabi ko sa inyo last week, na hindi dapat tayo naniniwala sa mga fake news, yung mga nag-i-spread ng mga text messages or chat messages na magkakaroon ng earthquake na ganito kalakas, sa ganitong oras, sa ganitong area. Okay, so wala pa tayong ganun technology. We cannot predict earthquake. It can happen anywhere without warning. And of course, ayan, they occur most frequent at tectonic plate boundaries and on faults. Ayan. So, of course, last week ay napag-usapan din natin yung definition natin ng faults. When we say faults, these are fractures on rocks. Ayan, yan yung nakita ninyo dyan sa picture natin, yung guhit dyan sa ating rocks. And then, yung sa next, nasa right side naman natin ay yung ating San Andreas Fault. Ayan. So, fractures or zones between two blocks of rocks. And of course, nag-demonstrate tayo ng different types of faults natin. We have yung deep slip faults, which is yung ang movement niya is vertical yung movement, nag-move up and down yung mga blocks niya. So, kina-classify natin siya as normal and reverse fault. So, kapag normal fault, ang movement ng hanging wall ay downwards. Kapag naman na reverse fault, ang movement ng hanging wall ay upwards naman. Okay, and then, yung isa pang klase ng fault natin is the strike slip fault, which is horizontal naman ang kanyang movement. Okay? Now, for this week, ayan, kasama pa pala natin na pag-usapan yung effects ng earthquakes, which is yung ground shaking, surface faulting, liquefaction, slope failures, and of course, kasama dyan yung fires and tsunamis. For this week, ang pag-uusapan na natin is to identify the difference between earthquake epicenter and focus. And then we'll also describe the strength of an earthquake based on its magnitude. And then describe the intensity of an earthquake in terms of its effect. And then lastly, we are going to identify the different active and inactive faults here in the Philippines. Okay? So, tingnan natin, meron na ba tayong mga, ayan, meron na tayong mga viewers natin. And I know, excited na kayo sa ating video lesson for this week. Sige, panoorin natin.
Hello, grade 8 learners. I am Ma'am Patrick Erica A. Cancel, your science teacher for today. And for this lesson, we are going to talk about the anatomy of an earthquake, and how its strength is measured. The most essential learning competency that we will cover are: first is to differentiate the epicenter of an earthquake from its focus. Second is to differentiate the intensity of an earthquake from its magnitude. And third is to differentiate inactive and active faults. The objectives of this lesson are the following. First is to identify the difference between earthquake epicenter and earthquake focus. Second is to describe the strength of an earthquake based on its magnitude. Third is to describe the intensity of an earthquake in terms of its effects. And lastly is to identify the different active and inactive faults here in the Philippines. Are you ready to learn something new today? Let's start! The Philippines is located in a tectonically active region called the Pacific Ring of Fire. This is where numerous earthquakes and volcanic eruptions occur. The archipelago is surrounded by subducting tectonic plates, such as the Philippine Sea Plate in the east and the Eurasian Plate in the west, and it is manifested by the offshore earthquakes along the different trenches in the Philippine Trench, the East Luzon Trough, the Manila Trench, Negros Trench, Sulu Trench, and the Cotabato Trench. Most of the inland earthquakes are caused by the movement of the 1,300-kilometer-long Philippine Fault. It traverses from the Ilocos region in the north to eastern Mindanao in the south. Movements along other active faults are responsible for the present-day high seismicity in the Philippines. No one can stop earthquakes from happening, but there are things people can do to avoid or reduce the loss of lives or damage to properties. The first thing is to have a clear understanding of the occurrence of earthquakes. Where does an earthquake start? Although the ground beneath us seems solid, it is actually in constant motion. We don't usually see it, but we can experience it through earthquakes. The Earth's crust is broken up into irregular pieces called the tectonic plates, and these large pieces of crusts were formed by the combination of gravity and the rising heat from the Earth's core. As tectonic plates move past each other along fault zones, they sometimes get stuck. The pressure builds, and when the plates suddenly slip, energy is released in the form of seismic waves, which causes the ground to shake. And this is known as an earthquake. The focus is the place inside the Earth's crust where the earthquake originates. And the point directly above the focus on the Earth's surface is known as the epicenter. When energy is released at the focus, the seismic waves travel outward from that point in all directions. There are different types of seismic waves, each one traveling at varying speeds and motion. It's these waves that we feel during an earthquake. We'll talk more about seismic waves on our next discussion. How strong is an earthquake? Now, the strength of an earthquake can be described in two ways: through its magnitude and through its intensity. Magnitude measures the energy that is released from the source of an earthquake. It is determined from the measurements of a seismograph. The greater the magnitude, the stronger the earthquake. Earthquakes with a magnitude of 2 may or may not be felt by people. Earthquakes that are felt by people have a magnitude of 4. Magnitude 6 and above can lead to a lot of damage in a highly populated area. The intensity of an earthquake gives us an idea of how strong or weak an earthquake is. By describing the effects of the shaking on the people or surroundings. Earthquake intensity is a ranking based on the observed effects of the earthquake on each particular place. Therefore, each earthquake produces a range of intensity values ranging from highest at the epicenter area to 0 at a far distance from the epicenter. The Philippine Institute of Volcanology and Seismology, or PHIVOLCS, uses the PEIS, or the PHIVOLCS Earthquake Intensity Scale, to describe the intensity of earthquakes here in the Philippines. To distinguish the two, the intensity is expressed in Roman numerals, while the magnitude is expressed in Hindu-Arabic numerals. Where do earthquakes occur? A fault line is defined as a geological fracture wherein the movement of the masses of rocks has displaced parts of the Earth's crust. A sudden movement of a fault line may produce an energy that can trigger a powerful earthquake.
Faults can be classified as active or inactive.
Active faults are structures in which we expect displacement to occur. It is a fault that is likely to have another earthquake sometime in the future.
Faults are commonly considered to be active if there has been movement observed or evidence of seismic activity during the last 10,000 years.
Active faulting is considered as a geologic hazard and is related to earthquakes as a cause. Inactive faults are structures that we can identify but do not have earthquake activities. An inactive fault is an area that had not displayed any seismic activity for more than 10,000 years. In the Philippines, there are 5 active fault lines: the Western Philippine Fault, the Eastern Philippine Fault, the South of Mindanao Fault, the Central Philippine Fault, and the Marikina or the West Valley Fault System. Since we cannot predict when and where an earthquake will occur, knowledge on earthquakes is important. In disasters like this, preparation is the key. One of the most frightening natural phenomena is the earthquake. The Philippines is always hit by earthquakes that can cause damage to environment, infrastructures, properties, and may also result to loss of lives. We can lessen these damages only if we are prepared and knowledgeable about earthquakes. I hope you learned something today. I am Ma'am Patrick Erica A. Cancel, and this is Science Matters, where learning never stops.
Ayan, so we are back. And of course, I hope ay marami kayo natutunan sa ating video lesson today. Pero syempre, i-discuss pa rin natin yung mga important competencies na dapat nating makover for this week. So, sige, tingnan natin for our summary. Ayan. The photo that you see is actually the anatomy of an earthquake. Yan. So, you see the focus. This is where the earthquake starts. So, kapag, di ba, in the fault line, ayan, the pressure builds, and then kapag nag-slip siya, ayan, so pag nag-slip siya, magre-release siya ngayon ng energy, and the area kung saan nag-originate yung pag-re-release ng energy, that is our focus. Okay? And then, directly above the focus, ayan, directly above the focus will be our epicenter. Ayan. So, tatandaan lang natin, between focus and epicenter, focus is found beneath the rock. Sa ilalim siya, sa loob siya. Okay? And then, the epicenter ay found sa surface. Ayan. So, nasa surface yung ating epicenter. So, yun lang yung tatandaan natin sa kanilang dalawa. Same naman yung kanilang location. Sa surface lang yung isa ay nasa underneath ng ating rocks. Now, tingnan naman natin yung ating magnitude and intensity. Ayan. So, pag sinabi nating magnitude, this is the energy released at the source of the earthquake or dun sa ating focus. And this is measured by seismograph. Now, tatandaan natin, magnitude is the same anywhere. Pag isang earthquake lang pinag-uusapan natin, no? So, for example, a magnitude of 5.7 na earthquake, for example, anywhere in the Philippines yan, kung anywhere kung saan man siya naramdaman, magnitude of 5.7 yan. So, kung ang origin niya is for example, sa Occidental Mindoro, pag naramdaman siya sa Batangas, sa Cavite, sa Laguna, sa Metro Manila, still the magnitude is 5.7. Okay, so hindi siya nag-change. Now, sa intensity naman, okay, the intensity, ang pinag-uusapan natin dito is the strength of shaking as perceived by, for example, by humans o kaya as we relate them to infrastructures. So, ibig sabihin, itong intensity can vary from one place to another. So, mas malakas ang intensity na nafe-feel natin as we go nearer doon sa ating epicenter. So, habang palapit sa epicenter, palakas ang intensity, and habang lumalayo naman tayo sa epicenter, humihina ang intensity until hindi na siya nararamdaman. And of course, meron tayong sariling intensity scale dito sa Philippines, which is the PEIS or the PHIVOLCS Earthquake Intensity Scale, which is different sa intensity scale ng ibang country. So, bakit naiiba? Kasi the infrastructures here in the Philippines are different from the infrastructures sa ibang bansa, sa ibang country. Like, for example, meron tayo dito, mostly ang mga bahay natin, for example, ay mga kubo o kaya ay mga made of cement. So, sa ibang bansa, iba rin naman ang materials ng kanilang construction. So, naiiba ang intensity scale nila kasi magkakaroon ng ibang effect yung shaking dun sa infrastructures nila. Okay? So, next tayo, ang susunod nating pag-uusapan is yung active and inactive faults. Ayan. So, active faults are structures in which we expect displacement to occur. So, ito yung mga faults na nagpo-produce ng earthquakes, kung hindi man na regularly, ay meron pa rin silang displacement. Now, there is movement observed or merong seismic activity during the last 10,000 years. As compared sa inactive faults, na na-identify natin sila, nakikita natin sila, kaya lang hindi na sila nagpo-produce ng earthquakes or wala na silang seismic activities. Okay? So, during the last or for more than 10,000 years, sila ay hindi na gumagalaw. Kaya lang, i-clarify lang natin, itong mga inactive faults na ito ay hindi na totally gagalaw. Okay? So, meron pa rin silang chance na gumalaw, kaya nga lang, kina-classify sila as inactive kasi for more than 10,000 years, wala na silang movement. Pero hindi natin masasabi ang panahon, di ba? So, katulad ng sinabi ko sa inyo before, hindi natin na-predict kung kailan nagkakaroon ng earthquake. So, itong mga inactive faults na to, meron pa rin silang chance na gumalaw pa. Okay? So, ayan. So, tingnan natin kung naintindihan ba ng ating mga students. So, I did not put a quiz today para ma-feel natin. But then, kailangan kong makita kung na-understand nyo ba yung lesson natin for today. Sige nga, tingnan natin, Sir Nick. Pa next, ayan. Now, did you understand the concepts that we discussed today? So, tingnan natin. Sige, pa-comment tayo ng happy or ayan, happy emojis kung na-understand ninyo yung lesson natin today. And then, kung sad naman ay not quite. Ayan. So, kung kailangan nyo pa ng additional na instructions or lessons, ayan, titingnan natin. Sige, habang naghihintay tayo ng mga answers ng ating mga students, syempre mag-shoutout muna tayo to Caitlin. Caitlin ay ang ating early bird, ayan, from G8 Masunurin. And then, of course, we have from G8 Maagap. Ayan, good morning to Ma'am Mavic, ayan. And Ma'am Sally, ayan, nanonood sila. And then, siyempre tayo. We also have from G8 Makakalikasan, Maasahan, Pagmahal, and of course, G8 Magalang, ayan. Ayan. So, ayan. So, I guess, ay naintindihan naman ng ating mga students. I know, medyo late yung announcement natin ng synchronous class, pero pwede niyong balikan ito, pwede niyong i-share sa inyong mga classmates. And of course, yung link natin ay nasa Facebook group and sinend ko sa inyong mga group chats. Pwede niyong balikan para mapanood ninyo and matulungan kayo sa lessons niyo for this week. Ay, sige, tingnan natin kung anong gagawin natin for Moodle. Ayan. Medyo mahaba lang yung Moodle natin this week, no? Pero meron pa na maiksi na yan as compared dun sa original. Yan na lang yung nilabas ko ngayon this week. Next week, meron pa ulit. Ayan. So, Learning Resource 1.2, Focus and Epicenter. And then, Learning Resource 1.3, Magnitude and Intensity. And yung mga learning tasks natin, 1.3, Anatomy of an Earthquake. Mga online quiz yan lahat. Mga 5-item quiz lang naman yung mga yan. And then, 1.4 and 1.6 ay online quiz. And of course, yung mga hindi pa nakaka-enroll sa ating LMS, posted na ang ating enrollment keys and yung mga step-by-step procedure kung paano mag-e-enroll. And ayan, nakalagay din dyan sa ating screen yung tamang LMS course na dapat ninyong makita. Kailangan yung my name ko. Ayan. So, sana naka-enroll na kayo, no? Ayan. So, next, sa module naman, anong mga kailangan nating answeran sa ating module? Tignan natin. Sa module natin, ayan. So, learning resource, the Quake starts, pages 11 to 13, and then nahati siya. Meron pa kayo ulit babasahin sa page 15 to 16. And then, learning task 1, meron kayong babasahin dyan na short article, and then you will answer the guide questions. Kaya makikita niyan sa page 13 to 15. And then, yung learning task 2 natin is a matching type. 5 items lang yata ito on page 15. And then, learning task 3, multiple choice, which is found on page 17. Okay? So, ayan. So, tingnan natin. Ayan. So, dumadating na yung mga answers ng ating mga students. Ayan. Na-understand naman daw nila yung ating mga lessons for today. So, I will be seeing you next week for week 3. Still earthquake pa rin. I think ay seismic waves naman yung pag-aaralan natin. And paano ba natin ginagamit yung seismic wave para malaman yung composition ng interior ng Earth, di ba? So, alam natin, wala pa nakakarating sa interior ng Earth, no? Pero alam natin yung composition niya. And that is due to seismic waves. So, yun ang pag-uusapan natin next week. I hope ay makasama ko kayo next week. Meron tayong makakasamang MDL teacher. And, ayan. So, I'll see you next week only here on Science Matters, where learning never stops.